I was told I'm getting a special entrance music, but at the end, oh, it's a surprise. Okay, I didn't say anything. Okay, hi everyone. I'm going to talk about a machine learning project I've been working on at my company, commercetools. This used to be a 90-minute presentation, and I had to delete a lot of slides to make it 20 minutes, so let's see if I succeeded. Okay, next slide, please. Okay, first some things about my company, commercetools. So commercetools offers an e-commerce platform as a service. So anyone who wants to sell something online, they are interested in our platform, and they can. We basically offer a way where you can manage all these processes that are related to e-commerce. So managing your product database, or managing orders, managing your customer data, all these things. We don't do the front end, but we have the platform for the back end. And so the main product that we have is the REST API, where you can manage all these things. Yeah, I won't go into detail there. Next slide, please. And on top of the API, we also offer a user interface where people can manage all the e-commerce products. So the product data, the names, the images, the descriptions, all these things they can manage in this interface, and as well as our API. Okay, the project that I'm going to talk about today is machine learning for category recommendations. So as you can see, in e-commerce you have a lot of products. So for example, these two images of shoes. And what you want to do is you want to assign the right categories to all of these products. So these two shoes could, for example, be categorized for sports, or for shoes, or for women. So there's quite a complicated category structure that you usually have in e-commerce. And there are usually a lot of categories that you need to deal with, so it's quite a pain for category managers to always assign the right categories to their products. So this is why we thought machine learning would be a good way to help there. And our goal is not really that people add the product to the database and then automatically assign the categories, but the goal is more to filter the categories, because there could be thousands of categories for different projects, and we want to show them the most relevant ones first. So this is what we want to do with machine learning here. And this is just the general tech that we're working with. Yeah, I won't go. I will mention some of these during the talk. Okay, now if we want to build a machine learning system that recommends categories, we have a bunch of challenges. I'm going to talk about 3 major ones now. So the first one is that every online store has a different category structure. So remember that our customers are all different online shops. So there could be one shop, so Rewe, for example, is one of them. So one shop only sells groceries, one sells fashion, bicycles, home supplies. So there could be very different industries, and of course every different shop has a very different category structure. And even if the store is in the same industry, they still usually have vastly different category structures. So for example, if you have this image here, then in one store this could correspond to fashion men jeans, or in another store this could correspond to clothing pants, so there could be very different category structures. And if we want to build a machine learning system that recommends unique categories, this is a bit of a challenge, because you don't have a clearly defined class set that you can use. So one way to deal with this would be to train a machine learning model for every single one of our customers, with every single unique category structure that we have. So this would be quite annoying in operations to maintain all these different models, but of course this would allow us to have highly specific models that are specifically trained for these categories. Second option is the one that we actually used. So this is the idea that we just have one machine learning model that recommends from a broad set of product categories. And now to manage that, in the end, we only recommend categories that are highly specific to the specific stores. We need a separate matching algorithm in the end. But the main machine learning classifier that we built just recommends general categories. So I'm going to talk about how this matching process works later. But this is basically what we used in the end, mainly because of these reasons. So with the first options, if you build multiple specific models, you of course have very high accuracies for the specific stores, and there's no category matching necessary. This is the advantage. But with this model, it's just more flexible, it's easier to deploy, And it also works for stores with little data. So some of our customers, they don't have a lot of products, so it's not easy to fit models just based on their data. But if we instead collect all data from all our customers and build a general model, then this allows us to just have more flexibility there. Okay, next slide, please. This was the one challenge. Second challenge, product data is diverse and unbalanced, which is hard for feature selections. So these are just some examples of the usual products that you're dealing with. And of course, if you now think about what features do we want to use to predict categories, you can think about names, images, prices, descriptions, sizes, brands, colors, expiration dates. So it's just a lot of stuff, and the problem is that this is not really unique. So there's a lot of missing data that exists for certain products, but it's also that certain product attributes only exist for a specific set of products, but not for another one. For example, for milk, you could have an expiration date. For T-shirts, you have colors and sizes, but there's just a lot of variance there, so it's hard to define the features that you want to use. Now, what we did is we just focused on names, images, and descriptions. First of all, because it's easier, and we don't have to deal with all this missing data that we can get in practice, but also because these three variables just carry the most information. So if I show you a certain product name and an image, you probably know which categories fit to it. Whereas if I show you a price and size, you won't know much. So these three variables is what we focused on just to make it easier for the start. Okay, this second challenge. Now, the last challenge that I want to talk about, of course, there's a very large class set. So if you think about category recommendations, Amazon or eBay, they have over 50,000 categories in their database. So this is not a typical machine learning problem where you want to say, classify an email as spam or no spam. So these were the typical examples. But here you have a class set of, well, if you really want to go deep, over 50,000. So this is hard to do in practice. What we did to tackle this problem is we decided to select a broad set of categories which are rather abstract terms. So this is just a selection of a few of them. They're usually one or two words, and they are supposed to cover a lot of the use cases that we have. And to reach the more specific categories that our specific stores have, we rely on this category matching procedure that I'm going to talk about later. But for this, we just selected these set of categories. In the end, so in our current version, these are 723. And of course, there's a trade-off. So the more categories you have in your model, the larger is the coverage. So the more categories you can actually predict if the use case is there for the customers. But the more you have, of course, the lower your accuracies are going to be. So there's a trade-off, and for our current version, we have 723, which are specific to the customers that we actually have, because these are also the use cases that we encounter. So these are not, so some categories that Amazon might have, we don't need them, because we only need to recommend categories for the customers that we have. And once we get more customers with different categories, we can adapt our model to these cases. But these are the ones that we work with so far. Okay, now a short overview of our approach. So what we want to do is we want to have a machine learning model for images, for names and descriptions. And these should recommend from this broad set of 700 categories. And then there's a separate matching procedure at the end that matches to the category trees of specific stores. Okay, now I'm going to talk about these models in detail, not in detail, but separately. So first, the model for product images. The machine learning model that we used there is probably not very surprising. So we used a convolutional neural network for this. I cannot give you an introduction to neural networks in general, but so the basic idea of convolutional neural networks is that you build complex representations by combining simpler representations. And this is also similar to what happens in the brain. So if your brain has to detect a certain visual entity, like a face here, for example, it starts by recognizing simple lines of simple orientations, and then combines these representations to detect an edge, for example, and then it combines edges to detect shapes like squares or circles. And if you do this more and more abstract, at the end you can recognize the whole face. So this is the idea of building feature detectors for simple features and then combining them to get more complex stuff. And For the model that we built, we used an approach called transfer learning on the pretty famous neural network called Inception v3. This was developed by Google and it won the ImageNet competition in 2015, I think. And so this is all open source. You can use this in the library TensorFlow. We use Python for it. And all of our data runs on Google Cloud. And we also use the machine learning services from Google Cloud. So we trained this model on Google Cloud as well. So, and yeah, transfer learning is just this is an idea. This is the architecture of this Inception network. I obviously cannot go into detail there. It's just, well, a set of consecutive convolutions and max pooling layers and dropout layers. And in the end, you have a classification for the categories. But I can't go into detail here. So just one sentence about transfer learning for those of you who don't know it. The idea of transfer learning is that you take a neural network which has already been pre-trained on a large data set and which has already been proven to be pretty robust for image classification. And now you want to have the prediction specific for your use case. In our case, the 723 categories that we want to recommend. So what you do is you don't retrain the network from scratch, but you only cut off the last classification layer and then add nodes for your classes that you want to predict. And then you only retrain this last layer. This is the idea of transfer learning. This, of course, saves you a lot of resources and time, but still makes it quite specific to the use cases that you want to have. Okay, this is what we used for images. Now, for names, for product names, these are just some examples of how product names can look like. So they're usually quite simple. So this is not high-level natural language processing where you need some detailed semantics. They're usually rather straightforward. Most important step here is that you have a proper set of pre-processing steps that you apply to these product names. To do this, we use these libraries that I mentioned there in Python as well. So the steps that you can do is spell checking, for example. Some of the product names don't have the correct spelling, so it might be better to spell check them first. Translation is also something that we need to do because in our company, we don't only have English data, but of course, if you want to build a machine learning model, you need to decide for a language. So you want to build this in English, but all the data that is in German or in Swedish, we first need to translate it to English. So we just use Google Translate for it. Of course, there's some error that can happen, but since these product names are usually straightforward and not very niche, this usually happens, works quite well. You need to tokenize them, so you have the whole product name, and tokenization just means that you identify the single units in the text. You need to normalize them, so in our case we just lowercased all the product names that we have, and we also deleted some special characters that we just don't think are very useful to make predictions from. So these are all just steps to reduce the variance in the data, just to make it easier to have a model fit that is robust. We also do Limitization. Limitization just means to find the word stem of a word. So for example, if you have the word apples, the word stem is apple. So for the machine learning model, you're really only interested in the fact that it's an apple, and it's not so important in our case to find out whether it's multiple apples or one apple. So we just use the word stem, again, just to reduce the variance that we have in the data. Phrasing is another thing you can do. So in the example here, if a product name contains Louis Vuitton, for example, you don't want your machine learning model to think that Louis and Vuitton are two separate entities. This is really only one entity that has predictive value for the category. So you want to detect these phrases and mark them, for example, here with an underscore. And if you want to do that in Python, the library gensim, for example, has some implementations for this that you can use. And the last thing, you also want to do word removal. So word removal just means removing uninformative words. So for example, in product names, these are words like and, or, not, all these things that don't carry any specific meaning to the predictions that you want to make. And we also have a blacklist of certain words that we want to exclude. So in e-commerce, for example, if a product name says Nike shoes, men's, blah, 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 on sale in this case doesn't really have any information about the category that we want to use. So we have just a certain set of entities and words that we realized they're not so important for prediction models, so we excluded them as well. Okay, now we have these pre-processing steps. I realize, okay, never mind. So the next slide is about vectorization, which I should have put before this, but now preview on the recommendation, on the classifiers that we used. So we just tried a bunch of classifiers in scikit-learn, and logistic regression turned out to perform best. Yeah, not much more to say about this than this. So we tried naive Bayes, random forests, XGBoost, and support vector machines, and logistic regression performed best. So this the simplest classifier of them all, but since the product names are not that complex, that might not be too surprising that logistic regression performs quite well in these cases. Okay, this is a slide about vectorization, which I should have put before. So remember when we had the pre-processing steps, then after that, machine learning models, they deal with numbers and not with strings. So you need to convert the strings that you have to numbers. And this is called vectorization. I'm going to quickly mention 3 approaches. So the simplest approach of them is called a bag of words. What you do there is you just take all the words, all the unique words that occur in your data set, and you make a column for each of them. And then if you want to vectorize a specific product name, you just put a 1 for the word, for a word if it occurs there, and you put a 0 if the word doesn't occur in the product name. So this just gives you one vector which represents the product name that you currently have. Disadvantage is that this is a very large vector, so it's a very sparse vector which contains a lot of zeros and only very few ones, but this does the job in terms of vectorization. But it's hard to deal with because it's so sparse. Second one is called TF-IDF. Can't go into detail there, but the basic idea is you do the same thing as you do with bag of words, but you weight words differently. And the main idea is that you weigh words higher if they do not occur frequently in the data set. So the idea is if you have a word like the, which can occur maybe in most of your product names, this doesn't carry a lot of predictive value for categories because every name has it. And what you want to do is you want to weigh the words higher that occur less often in the data set. For example, Nike, if you see the word Nike, this carries a lot of information about the category, so this is weighed higher. Ignore this lower part for now. Third approach that we tried, word2vec. I'm sure you've heard it at this conference now a bunch of times. This is just basically what you do is you train a 2-layer neural network that predicts context words of a word. So here, this is the basic architecture of the network. On the left-hand side, as an input, you just put in the word, let's say dog in this example. And on the right-hand side, you put context words, so words that surround the word with a certain window size. And now you just train this network to predict from the word all the context words. And for word2vec, in order to get the word vector that you're interested in, you now just look at this hidden layer. So this is where you get your word vectors from. And what this does, it deals with a sparsity problem. So in this bag of words approach that I talked about, you end up with a lot of zeros in your vector, and this is just one way to make it more dense and more informative. Okay, this is word2vec. Yeah, so in the end we used TF-IDF, which worked best. So if you remember the combination of the pre-processing steps, then TF-IDF, and then logistic regression is what we used for product names. And this slide should just tell you that the same thing worked out for product descriptions. So in the end, we used the same approach, same pre-processing steps, and same classifiers for product descriptions. You could think that descriptions are more complex, so they have more detailed semantics. Maybe word2vec would have worked better there, but no, we just ended up with the same architecture for both. Okay, now the last step. So now we have an image model, we have a name model, we have a description model. And now we want to predict these categories. First thing that we do is we just average the class probabilities of all these different classifiers to get just one general set of predictions. You can get more fancy there and build ensemble classifiers, so a separate classifier that's built on top of the classifiers. But in our case, we did this and it worked fine so far, but we might extend it in the future to have something more complex there. Now we have a unique set of categories. Now we need to match them onto specific store categories. And for this, we used a word2vec model. So let's say the general category that we predicted was T-shirts. Now we have two different stores. In one store, this might correspond to the category t-shirts and sweatshirts, and in another store this might just correspond to the category shirts in general. Now you want to have a model that can match and find the similarity between these strings. And yeah, for this we used Word2Vec, and this was trained on a common set that's used in Word2Vec, just a set of Google News articles, so we didn't use an e-commerce data set there, mainly because the news article set just contains more complex semantics than a typical e-commerce data set would have. And we also didn't have that much e-commerce data, so this is why we used this news article data set to identify these similarities. Okay, 40 seconds left, but I think I'm almost there. You can skip this slide. So now we have our machine learning infrastructure for all of this. Now we build a REST API on top of it in the Python library Flask. This is just a simple example of how a request like this could look like. So on top there you have to say for which store you want a recommendation and for which product ID. And then what goes on in the backend is we take this product ID and check in our database for a product name and a product image. And then we run through all these machine learning predictions. And then we output as JSON the results. So for this product, you would have the category path men, accessories, backpacks. And then you also get the ID of the category. So this is what we use. And this API is then also integrated in the user interface that I talked about. So just if you want to assign categories in our user interface, you can click on the product and then click on recommendations, and then you see the categories that are recommended. Okay, that's it. Thanks a lot.